Black holes are real. We have photographed them. We know they exist, swallowing stars, tearing planets apart, crushing entire solar systems into points smaller than an atom. That part is not in question. But here is the part almost nobody tells you. The same math that proves black holes exist also proves something else can exist. Something that does the exact opposite job. Something that cannot pull anything in, no matter how hard you try to push it there. Something that only pushes out, forever. It has a name. Scientists call it a white hole. And once you understand what it actually is, you will never look at a black hole the same way again. Here is the wild part. This is not science fiction. This is not a fringe theory some random YouTuber made up for views. If a black hole is the ultimate cosmic drain, an abyss that consumes everything that dares to cross its border, the equations say there has to exist a cosmic fountain somewhere too, a place where matter, light, and energy erupt outward without end, and where nothing, absolutely nothing, is ever allowed to enter. Total hunger on one side. Total refusal on the other. Two absolute opposites, sitting inside the exact same set of equations. So what happens when you slam them together? Stay with me until the end, because you are about to find out why some of the sharpest physicists alive today believe every black hole in existence, including the monster sitting at the center of our own galaxy right now, is secretly getting ready to become something else entirely. Before we go any further, ask yourself something. If these two objects are perfect opposites of each other in the math, and one of them is sitting quietly at the center of nearly every galaxy in the universe, including our own, why has almost nobody outside of physics ever heard the other one mentioned by name? Is it because it is simply too rare to matter? Or is it because the truth about it is stranger, and far more unsettling, than most people are ever told? Keep that question in your back pocket. We are going to answer it before this video ends. Let's start with the monster you already think you understand. A black hole is usually described as an object, but that description barely scratches the surface. It is better understood as a one-way street carved directly into the geometry of reality. Once you cross a certain invisible line, there is no version of physics, no amount of thrust, no clever trick, no exotic technology that lets you turn around and go back. That line is called the event horizon, and it might be the single most absolute boundary that exists anywhere in nature. Think for a moment about what it actually takes to escape a planet's gravity. Earth has what scientists call an escape velocity, the exact speed an object needs to break completely free of the planet's pull. For Earth, that number sits at roughly 11 kilometers per second. Leave our planet behind and try to escape the gravity of the Sun itself, and that number jumps to around 618 kilometers per second. Big numbers, but not impossible ones. Now cross the event horizon of a black hole, and the escape velocity required does not simply climb higher. It rockets past the speed of light itself, 300,000 kilometers every single second, the fastest speed anything can ever travel in this universe. Once escaping requires exceeding the cosmic speed limit, escape stops being difficult. It becomes mathematically, physically, permanently impossible. Now picture exactly what falls into that boundary, day after day, for billions of years. Entire stars, some 10, 20, even 50 times more massive than our own sun, get pulled in and shredded apart by tidal forces so extreme they would stretch a human body into a thread thinner than spaghetti, a process astrophysicists have actually nicknamed spaghettification. Whole planetary systems, gas clouds spanning distances of trillions of kilometers, entire pockets of the galaxy, get slowly funneled down into a single, unthinkable point smaller than an atom. This point is called a singularity, a place where our current laws of physics simply break down, where density becomes infinite, and where space and time themselves stop behaving the way they do everywhere else in the universe. A black hole, in every meaningful sense, is the most perfectly engineered vacuum in existence. It has exactly one function, and it performs that single function with terrifying, flawless efficiency. Pull everything toward the center. Let absolutely nothing leave. This is the baseline. This is the villain everyone already fears, the one whose photograph made headlines around the entire planet, that glowing, fiery ring of light wrapped around a circle of total darkness. Keep this image locked firmly in your mind, because we are about to take everything you just learned and turn it completely inside out. And before you assume you already understand exactly what a black hole is capable of, consider this. Not even light can escape one, which means, in a very real sense, a black hole is not simply dark. It is the one place in the entire universe where the concept of seeing inside stops meaning anything at all. Every photon, every particle of light that has ever tried to carry information back out from beyond that horizon, has failed every single time, without exception, for as long as black holes have existed. That is the level of totality we are dealing with. Now hold on to that thought, because the object we are about to introduce breaks that totality in the most complete way physics allows. Now flip every single detail you just heard, one by one, and you begin to understand an object that most people have never even heard mentioned. Imagine something with an event horizon, just like a black hole has, but with one twist that flips the entire concept on its head. Instead of a boundary you can cross going in but never crossing going out, imagine a boundary you can never cross going in, but one that constantly, endlessly, violently ejects everything from inside it, outward, forever. And here is where things get genuinely strange. Even if you were somehow moving at the speed of light itself, the fastest velocity permitted anywhere in this universe, the space surrounding a white hole would still push you away with infinite force before you ever got close enough to touch it. You cannot fall into a white hole. You cannot approach a white hole. You cannot make contact with a white hole under any circumstance the laws of physics allow. Space itself, in the immediate neighborhood of a white hole, behaves like an invisible wall made entirely out of outward pressure, a wall that gets stronger, not weaker, the harder you try to push against it. And unlike its darker twin, a white hole never sits quietly, waiting patiently to devour something that wanders too close. It never rests. It never pauses. It continuously spews out streams of matter, blinding bursts of light, and staggering, almost unthinkable amounts of raw energy, seemingly from absolutely nowhere, as if reality itself were being fired out of a cosmic cannon that never, ever runs out of ammunition. If a black hole is the purest expression of hunger the universe has ever produced, absorbing everything it touches and returning nothing, then a white hole is the purest expression of eruption, releasing everything and absorbing nothing at all. It is, in the truest and most literal sense of the phrase, a cosmic repulsor, an object built entirely from outward force, with absolutely zero capacity to pull anything toward it, ever. There is another detail worth pausing on here, because it tends to surprise people the first time they hear it. A white hole is not simply a black hole with the arrows reversed on a whiteboard somewhere. It is what you get when you take the exact same equations describing a black hole and run the clock backward, mathematically, to the letter. Time reversal is a real, legitimate operation in physics, one you can apply to almost any equation describing motion. Apply it to the equations of a black hole, and a white hole is precisely, exactly, what falls out the other side. It is not a rough analogy. It is not a thought experiment invented for entertainment. It is the literal, formal, mathematical opposite of the object we just spent several minutes describing, sitting right there in Einstein's own field equations, waiting for anyone willing to look. Sit with that contradiction for just a second. One object that only takes. One object that only gives. Both fully permitted, both actually required, by the very same equations of general relativity that Einstein wrote down over a century ago. And that raises an obvious, almost unavoidable question. If these two things are mathematically perfect opposites of one another, mirror images down to the smallest detail, are they really two completely separate objects floating independently through the cosmos? Or is it possible, however strange it sounds, that they are secretly two ends of the exact same thing? Here is that question from earlier, the one I asked you to keep in your back pocket. Why has almost nobody heard of white holes, if they are just as mathematically real as black holes? Part of the answer is that we have never directly observed one. Every black hole photographed so far, including the famous image of the supermassive object at the center of the galaxy Messier 87, and the one released for our own galaxy center, Sagittarius A star, was detected because of how it swallows, by definition, would look almost the opposite. An object relentlessly pouring out matter and radiation from a region with no visible source feeding it. Some astronomers have even speculated that a handful of strange, unexplained high-energy bursts detected by telescopes could theoretically be candidates, though the overwhelming majority of physicists remain deeply skeptical, and for good reason, because there is a much simpler explanation waiting in the wings, one that does not require finding a single new object anywhere in the sky at all. This is exactly where the story stops being a simple comparison of who is more powerful, and turns into something far stranger than either object on its own. Back in 1935, Albert Einstein, working alongside physicist Nathan Rosen, proposed a solution to the equations of general relativity that mathematically connected the entrance of a black hole directly to the exit of a white hole, through a tunnel carved into the very geometry of space-time. Today, this theoretical structure carries a name most people have at least heard once, an Einstein-Rosen bridge, though almost everyone simply calls it by its far more familiar nickname, a wormhole. Here is the question that makes this idea genuinely impossible to ignore. Every single second, all across the universe, black holes are pulling in staggering, almost unimaginable quantities of matter. Gas, dust, entire stars, in some cases entire smaller black holes get consumed and merged. The largest black holes we have ever detected, the supermassive giants sitting at the centers of galaxies, contain the crushed mass of billions of suns packed into their cores, material that has been accumulating, uninterrupted, for billions upon billions of years. So where does all of that material actually go? Matter cannot simply cease to exist. That would violate one of the single most fundamental rules underpinning all of modern physics, the conservation of mass and energy, a rule that has never once been broken in any experiment ever conducted. Something has to happen to all of that vanished material. It has to go somewhere. The wormhole hypothesis offers an answer that is, frankly, staggering to actually sit with. What if the singularity buried at the heart of every black hole does not represent an ending at all, but instead a piercing? What if the crushing, effectively infinite density hiding inside a black hole punches straight through the fabric of spacetime itself and comes out the other side, not necessarily in our own universe, but somewhere else entirely? Perhaps in another universe altogether. Perhaps folded into another dimension. Perhaps stretched out into another point in time, distant past or distant future. And what erupts violently on the other side of that impossible tunnel is exactly the object we just described a moment ago. A white hole, endlessly ejecting every scrap of that swallowed material back out into existence, somewhere else, forever. Under this model, a black hole and a white hole are not two separate monsters locked in some kind of cosmic rivalry, circling each other across the galaxy. They are the two mouths of a single, continuous structure, an entrance and an exit belonging to one unbroken tunnel, stretched across the underlying geometry of the universe itself. Everything that appears to vanish into darkness on one side might, somewhere, somehow, be exploding back into blinding light on the other. But this beautiful idea comes with a devastating problem, one that kept it firmly trapped in the realm of pure theoretical curiosity for decades after Einstein and Rosen first proposed it. Traditional wormhole models, built from the original, classical Einstein-Rosen geometry, appear to be catastrophically unstable. The moment even a single particle of ordinary matter attempts to actually pass through one, the tunnel collapses instantly, sealing itself shut faster than literally anything, even light itself, could possibly make it through to the other side. For a long time, this seemed to be the final word on the matter. A gorgeous, elegant mathematical structure, permanently trapped as nothing more than a beautiful impossibility, a poetic idea with no way to actually happen. And that might genuinely have been where this story ended, if not for one of the most radical ideas circulating in modern physics today, an idea that abandons cosmic tunnels altogether and instead completely rewrites our understanding of what is actually happening inside a black hole. Comes out of a field of physics called loop quantum gravity, and one of its leading, most vocal proponents is the Italian theoretical physicist Carlo Rovelli. The claim sitting at the very heart of this theory is almost absurdly simple to state out loud, and yet it quietly overturns nearly a full century of assumptions about what a black hole fundamentally is. According to this theory, a black hole is not a permanent grave. It is a caterpillar, and every single one, without a single exception, eventually becomes a butterfly. Pause here for a second, because this is worth repeating slowly. Not most black holes. Not the small ones, or the young ones, or some special rare category. Every single black hole that has ever formed anywhere in the universe, according to this theory, is already, quietly, on its way to becoming a white hole. The one at the center of our galaxy. The ones formed from the collapse of dying stars. The ones astronomers photographed for the very first time in 2019, and again in 2022. All of them, according to this framework, are mid-transformation right now, at this exact moment, while you are watching this video. Here is the actual reasoning behind that startling claim. General relativity predicts, cleanly and consistently, that matter falling into a black hole gets crushed down into a singularity, a mathematical point of truly infinite density and precisely zero volume. But quantum mechanics, the branch of physics that governs the smallest imaginable scales of reality, absolutely refuses to allow anything like that to actually happen. Quantum theory insists that space itself has a minimum possible size, a smallest conceivable unit of length, sometimes referred to as the Planck length, a distance so small it makes an atom look like an entire galaxy by comparison. Nothing anywhere in this universe, according to the strict rules of quantum physics, is ever allowed to be compressed down into a true mathematical point of exactly zero size. There is a flaw, a hard, non-negotiable limit built directly into the structure of reality. And all matter falling relentlessly into a black hole eventually slams straight into that floor. So what actually happens when the crushing force of gravity meets an object that has already hit the absolute smallest size the universe will ever permit it to reach? According to loop quantum gravity, it cannot compress any further, not even slightly, and critically, it does not simply stop dead in its tracks. It bounces. Ravelli and his fellow researchers describe this moment as a state of maximum possible density, sometimes given the almost poetic name of a Planck star, describing the densest object the laws of quantum physics will physically permit to exist anywhere in the cosmos. And the very instant that limit is reached, the entire collapse violently reverses itself. The crushing, one-way implosion suddenly becomes an explosive, powerful rebound, with matter and energy recoiling outward with tremendous, staggering force. In other words, at that precise moment, the black hole quietly begins turning itself inside out. Now here comes the single detail that transforms this theory from merely strange into something that is genuinely, completely mind-bending, once you fully understand the relationship between gravity and the passage of time. Inside a black hole, gravity is so overwhelming, so extreme, that time itself slows down to an almost unimaginable crawl compared to how it flows for someone watching from safely outside. This is not idle speculation. It is a well-established, repeatedly confirmed prediction of general relativity, verified through real astronomical observation. According to Ravelli's model, the actual bounce itself, the precise moment where collapse abruptly turns into explosion, happens extremely quickly from the perspective of the matter that is actually undergoing it. But because of the extreme time dilation involved, that exact same bounce, when viewed from outside the black hole, from our perspective here on planet Earth, appears stretched out over an almost incomprehensible span of time. We are talking about a span measured in billions of years. This staggering fact means that a black hole which formed shortly after the very beginning of the universe could, right at this exact moment, still be somewhere in the middle of its bounce. The explosion, in a very real sense, has already technically happened. We are simply watching it unfold from the outside, in impossibly, agonizingly slow motion, stretched across a timescale that dwarfs the entire recorded history of human civilization finally completes, when a dying, slowly evaporating black hole has spent an unimaginable stretch of cosmic time quietly turning itself inside out. The theory predicts that it detonates. Not into nothingness, not into silence, but into a fully formed white hole, releasing absolutely everything it ever swallowed across the eons. Every crushed star, every consumed planet, every last fragment of information that ever crossed its horizon, all of it flung back out into the surrounding cosmos in one final, staggering, blinding burst of light and matter. If this model turns out to be correct, a white hole is not some abstract mathematical curiosity buried inside an equation, existing only on paper. It is the literal, inevitable destiny of every single black hole floating anywhere in the universe. Nothing gets erased. Nothing is ever truly lost forever. It simply waits, compressed down to the absolute limit the universe will allow, patiently, for its own precise moment to erupt spectacularly back into existence. It is worth being honest here, because a good story about the universe should never pretend to be more settled than it actually is. Loop quantum gravity is one serious, mathematically rigorous framework among several competing attempts to unify quantum mechanics with general relativity, and it has not been confirmed by direct experiment. No telescope has ever caught a black hole in the act of exploding into a white hole. No detector on Earth has recorded the signature Ravelli's model predicts. This remains, for now, one of the most compelling theoretical proposals in modern physics, not an established fact printed in a textbook. But that is precisely what makes it worth paying attention to. The history of physics is full of ideas that sounded like science fiction the decade before they were confirmed, black holes themselves included. Einstein's own equations predicted them in 1915, yet many physicists, including Einstein at times, doubted anything so extreme could actually exist in nature. It took over half a century, and eventually direct observational evidence, before the scientific community fully accepted that these objects were real, physical residents of our universe, rather than a strange mathematical curiosity. White holes, and the quantum bounce that may create them, could very well be sitting exactly where black holes once were, one confirming observation away from rewriting everything we thought we understood about how the universe recycles itself. Let that idea properly settle for just a moment, because it quietly reframes absolutely everything we started this video with. We began by describing two monsters locked in the most extreme possible opposition found anywhere in physics. One that consumes without any limit whatsoever. one that erupts without any limit whatsoever, one with a horizon you can enter but can never, under any circumstance, leave, one with a horizon you can never approach in the first place, no matter how you try. And yet, when you follow the mathematics, and now, potentially, the deeper quantum physics, all the way through to its logical conclusion, those two apparent opposites are not actually enemies locked in cosmic combat at all. They are two chapters belonging to the exact same underlying story. The universe, it seems, quietly refuses to allow pure, permanent destruction to exist anywhere without an equal and opposite act of creation patiently waiting somewhere on the other side of it. Every single point of absolute compression may ultimately be balanced, somewhere, at some point far off in time, by an equally absolute, equally violent release. Every apparent ending, encoded directly and permanently into the underlying mathematics of spacetime, quietly doubles as the seed of an entirely new beginning. So the next time you happen to see an image of a black hole, that now famous glowing, fiery ring of light bent dramatically around an abyss of total, impenetrable darkness, remember that you might not actually be looking at a graveyard at all. You might be looking at something closer to a chrysalis. Somewhere out there, perhaps unimaginably far away across the cosmos, perhaps unimaginably far off in the future, everything that has ever fallen helplessly into that darkness may currently be waiting patiently for its own moment to erupt spectacularly back into light. The single most destructive object we know of, anywhere in the entire universe, might, in the end, simply turn out to be nature's slowest, most patient, and most magnificent possible form of rebirth.